Welcome to a new video which is about continuity in limits. In this video I will explain the conditions of continuity in limit first and then solve 3 instructive examples regarding the subject. If this is your first time here and if you want to support this channel, don't forget to subscribe, click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. Here we see the definition of the continuity and we have a rule. Suppose that f is a function from set A to real numbers. A might be any set. If the limit of f of x when x goes to a from the right side is equal to the limit of f of x when x goes to a from the left side, and if that is also equal to f of a, and then we say that f of x is a continuous function at the point x is equal to a. Here actually this part is saying us that if limit exists at the point x is equal to a, so we can just summarize this as when x goes to a, limit of f of x, if that is equal to b, guys. In other words, if f of x has a limit at the point x is equal to a as b, and if that b is equal to also f of a, and then we say that the function is continuous at the point x is equal to a. Actually, we see this in a graph, obviously. Suppose that this is our function. Okay, we have such a function f of x, and at the point a, the function indicates the value of b. If you approach a from the left side and then we are approaching b, if you look at here, then we are approaching b. If we approach a from the right side also, and as you can see over the function, we are still approaching the b, and if that is also equal to f of a, as you can see, that indicates that f of a is equal to b. So if all of them are equal, and then we say that f of x is continuous at the point f of a. We have a nice question to summarize the continuity actually on it, and let's take a look at that question. Okay guys, in this question it says examine the continuity of f of x at the points x is equal to -4, -3, -2, -1 and up to 5. So the function is here, and as you can see at the point x is equal to -4 there is no any jump. All the points are filled. That means if you approach at the point x is equal to -4, if we approach -4 from the left and then from the right, there is no jumping, all the points are filled as well. So that means it is continuous. Okay, let me write it here. Continuity points at the point x is equal to, guys. We can say that x is equal to -4, there is a continuity. It is continuous. And similarly, if you look at -3, there is no jump, all the points are filled. That means at the point x is equal to -3, the function is also continuous. At the point -2, as you can see, still the left limit and the right limit are equal, and the function is defined at that point to the same limits. That means it is also continuous at the point x is equal to -2. If you look at -1, the left limit is +3, and the right limit is -2, guys. So there is a jump. That means it is not continuous, okay? So at the point x is equal to -1, it's not continuous. At the point x is equal to 0, which is right here, it is also continuous, guys. At the point 1, as you can see, there is no jump. All the points are filled. This point is filled. So that means at the point 1, it is also continuous. At the point 2, the same thing. At the point 3, okay, the point 3 is interesting because there is a limit, okay? If you approach 3 from the left, the limit is 3. If you approach 3 from the right over the function, we have also 3. But at the point x is equal to 3, the function is defined somewhere else. So we can say that limit when x goes to 3 from the left equal to limit when x goes to 3 from the right, 3, guys, right? So the left limit is equal to the right limit. There is a limit. But because this is not equal to f of 3, okay? Because f of 3 is defined somewhere else, which is at this point, then there is no continuity. So at the point x equal to 3, there is no continuity as well. At the point 4, we have this similar scenario here. If we approach 4 from the left, this is our limit. If we approach 4 from the right, this is our limit. And also the function is defined at the point x is equal to 4 at this point. So all of them are different. That means there is no for sure continuity. If you look at x is equal to 5, the left limit is -3, the right limit is -3, And also the function is defined at the point x equal to 5 as -3 as well. So all of them are equal. That means x is equal to 5. There is also continuity, guys. And let's take a look at our next question. Okay, guys, we have a new question, and it says for the function f of x, which is defined as sine square x plus 1, where x is less than pi divided by 2, guys. That is important. This is our first boundary. And the second boundary is when x is greater than or equal to pi divided by 2, this is our function. And examine the continuity at the point x is equal to pi divided by 2, guys. So in this case, we need to find out when x goes to pi divided by 2, guys. From the left, f of x, that has to be equal to limit of f of x when x goes to pi divided by 2 from the right also. Actually, when you approach it from the right, because of that equal symbol, okay, this is going to be related to approaching from the right side. So that is going to be equal to f of pi divided by 2, guys. Let's look at the left limit first. So we will evaluate this function first. Just let me write it here. Sine square of pi divided by 2 plus 1 is equal to, guys, sine pi divided by 2 is 1. Sine 90 degree is 1 because, and if you take the square of 1, which is going to be 1, of course, and 1 plus 1, which is going to be 2. So the left limit is going to be 2, guys. Is it equal to? Let's check it. And this part, when you approach pi divided by 2 from the right, then we're going to apply this function, which is cosine 2x minus 1. So if you put pi divided by 2 instead of x, then we're going to have cosine 2 times pi divided by 2. This is pi divided by 2 minus 1, guys. And as you can see, these are gone. So we have here cosine pi. So cosine pi minus 1, the question becomes this. And cosine pi is -1. So we're going to have from here -1 minus 1, which is -2, guys. And as you can see, the right side is -2, which is equal to this, guys, f of pi divided by 2. So this is also -2, guys. So as you can see, 2 is not equal to -2. That means, guys, there is no continuity at the point x is equal to pi divided by 2, guys. So it is not continuous at this point. And let's take a look at our last question. This is our last question, guys. In this question, f of x is defined as a piecewise function. When x is greater than 1, we have x squared plus n. When x is equal to 1, then the value of the function is defined as 5. When x is less than 1, then the function is mx minus 3. Because of this definition, guys, as you can see here, f of a is equal to b. So that means f of 1 has to be equal to, of course, it is defined as 5, but here everything should be equal to 5, okay? All the limits should be equal to 5. That means, in other words, when x goes to 1, the left limit has to be equal to 5 as well. So let me write it here. Limit when x goes to 1 from the left. This is our function that we're going to apply. Mx minus 3 has to be equal to, guys, limit when x goes to 1 from the right. This is our function, which is x squared plus n, and they are equal to each other, and they have to be equal to 5, guys. So here, for the first limit, if you put 1 instead of x, here, what we're going to have? We're going to have m times 1 minus 3, and then has to be equal to, guys. Here, if you put 1 instead of x, we're going to have 1 plus n, and all of them should be equal to 5, guys. If you take those two, so I'm going to have m times 1, which is m minus 3, and that is equal to be 5, guys. If you send this 3 to the right, then I'm going to have positive 3, so I'm going to have m is equal to 5 plus 3. This is a shortcut, by the way. For the people who don't know how I did this, I recommend you to take a look at one of my previous videos about shortcuts in calculations. Anyway, that's a different story. So from here, m is going to be equal to 8, guys. If this is the case, then m is 8. And if you take a look at the last two equalities, okay, then again the same thing, just send this one to right side, and it's going to be 5. Here it was positive 1, and now it's going to be -1. So from here we're going to have n as 4 as well. So because we are asked to find the value of m plus n, we can say that 8 plus 4 is going to give us the answer as 12, guys, which is B in this case. If you have any question, you can put them in the comment section below. Thank you for watching and hopefully see you in the upcoming videos.